Every second, Earth loses 50 grams of a gas so rare that once it's gone forever. It's not oil, not water. It's helium, the element we use to fill birthday balloons. But while we're letting it float into the sky, the world's 50,000 MRI machines are quietly depending on it to save lives, from ancient rocks to war zones. This is the story of a non-renewable ghost that's slipping through our fingers and the race to stop medicine from running on empty. Picture Earth, 4.5 billion years old, and deep inside its crust, a slow, invisible birth is happening. Uranium and thorium atoms, decaying over millions of years, are quietly giving off alpha particles, and each alpha particle is just a helium nucleus. This helium collects in tiny pockets, often trapped alongside natural gas. But the moment we drill into those pockets, or a volcano belches, that helium is released. And because helium is lighter than air, it doesn't stick around. It rises relentlessly through the atmosphere until it reaches the edge of space. There, the polar wind whisks it away at a rate of 50 grams per second. Every year, 1,600 metric tons just vanish into the void, never to return. Here's the kicker. Unlike carbon or water, which can be recycled, helium, once it's gone, it's gone. It's the only element on the periodic table that's truly unrecoverable. So next time you see a balloon float away, remember that helium is on a one-way trip off the planet. But what does all this have to do with modern medicine? That's next, where we'll see how the sun's gift ended up saving millions of lives inside an MRI machine. In 1868, during a total solar eclipse, astronomers pointed their spectroscopes at the sun's corona and noticed a mysterious yellow line. This was evidence of an element no one had ever seen on Earth. They named it helium, after the Greek word for sun, helios. It took nearly 3 decades before scientists finally isolated it from a uranium mineral here on our planet. But helium's true superpower wasn't revealed until much later. Its boiling point is a mind-boggling -452 degrees Fahrenheit, just 4.2 degrees above absolute zero. That makes it the coldest liquid in existence and absolutely essential for superconductivity. Inside every MRI scanner, enormous magnets must be cooled to these extreme temperatures to function properly. A single conventional machine guzzles roughly 1,700 liters of liquid helium just to get going. With about 50,000 MRI scanners around the world and 40 million scans performed each year in the US alone, modern medicine has quietly become utterly dependent on this fleeting gas. When you slide into that narrow tube, you're lying inside a magnet bathed in a substance that took the universe billions of years to create. And that's the problem. It's running out. Coming up, the painful history of helium shortages and why we're bracing for the next one. In the last 2 decades, the world has weathered 5 helium crises. Each one tightened its grip on hospitals, triggering price spikes and supply rationing. The 2022 shortage was a perfect storm. A fire at a Russian gas plant, the war in Ukraine, a Qatar plant shutdown, and the US government's decision to sell off its strategic reserve, together removing about 10% of global production capacity. That reserve, near Amarillo, Texas, once supplied 30% of the nation's helium. But the final sale began in January 2024, removing the critical buffer. Hospitals now face rationing. As one expert warned, a 2-week MRI shutdown means 1,000 people go unscanned, and at least 10% may have something critical that needs immediate care. Helium has become a geopolitical domino, toppled by wars, fires, and profit-driven sell-offs. But there's hope on the horizon. New technologies that recycle helium or eliminate the need for it entirely. Scanners that require just a balloon's worth. That's exactly what we'll explore in our next chapter, a balloon's worth of life. Despite its medical significance, helium is often treated like a party favor. The same element that reveals a brain tumor is allowed to drift away for a few seconds of celebration. Recycling is possible. Many MRI sites recapture boil-off helium, but most scanners release it into the air, missing the chance to reuse. The MRI industry has already cut consumption by 25% in 7 years, yet the vast majority of machines remain dependent. We're being forced to choose between frivolity and life-saving diagnostics, and the math isn't in our favor. A single MRI machine holds the helium equivalent of tens of thousands of party balloons. And right now, the balloon aisle is winning. But there's hope, and it's coming from the engineers. Philips has developed something called BlueSeal technology. It seals the magnet so tightly that only 1% of the helium a conventional scanner uses is ever needed. That's it, 1%. And so far, across all their installed systems, they've saved over 1 million liters of helium. That's not just recycling. That's breaking the dependency almost entirely. Other companies are racing too, developing zero boil-off systems that could make future MRIs virtually helium independent. But here's the catch. There are still 50,000 legacy scanners out there, all guzzling liquid helium. Replacing them will be slow and painfully expensive. So even with these breakthroughs, we're looking at years of shortages. One CEO called this moment the black swan event we always feared, a race between the escaping atoms and the engineers trying to break their dependence. So the question isn't really whether helium will run out. It's whether medicine can evolve fast enough before it does. Helium is more than balloons. It's a non-renewable resource powering MRIs and space telescopes. But we're letting it escape, and once it's gone forever. The good news is we can still save it. If you want more urgent science, subscribe and ring the bell. See you next time.